Alright everyone, and welcome to the next screencast for a class, and I'm going to today focus on the charting options within Excel. So the reason why we'd want to do a chart is because we want to be able to plot data and see trend lines and see trends in actual experimental data that we've collected. As an engineer, we have a lot of models that we're going to pull that's based on assumptions and theories, but oftentimes we need to match those theories and assumptions to the real world. And how we do that is through plotting data that we've collected in a lab through a variety of experiments, whether it's pressure, temperature, time, or whatever the data is. We want to plot that and model it to some physical parameter that we have, that we know, that we can see what's really the driving force behind what we're seeing. And in order to do that, we need to be able to somehow relate these two together. So in this lecture, in this lesson, we're going to focus on how we actually take raw data, plot it out, and then perhaps apply some very simple trend lines to the experiment to do that. And so let's start with the idea of importing data. And so if we want to import data, what we're really looking at doing is taking a data file that comes from an experiment or from some file and bringing it into Excel. And the nice thing is, Excel has abilities to import a variety of file types to bring in that data. So how do we do that? Well, we can actually go into first click the file, go into open, and you want to go to your computer and browse wherever the file is that you might want to have. In this case, I have my file hidden in Cthulhu Relay, and one of the things you'll find, and I kind of cheated because I already had this open, but typically Excel will default to having just all Excel files listed. So you won't see the files that you want, especially if it's a data file that is of some random type. Usually it's a text file, usually labeled as .dat or .txt. Sometimes it's a comma limited format, so it'll be a CSV file, but it doesn't matter what it is. You might first want to go into all files and click on that to show the data file that you want to do. And so here I have it cleverly listed as lecture3data.txt, so we can click on that. And the nice thing here is Excel is going to recognize, hey, this isn't an Excel file, so what can we do? So it's going to try to import it in different ways. You can say fixed with, which is kind of the dumbest way to do it, but but what that means is it will, if you go next, it will take and look for a specific length of size, and it will take everything on the left side of that width as one cell column and everything on the right side as another column. You can keep on adding a bunch of those back. It's not really the most powerful, and most file types are not listed in that way. Alternatively, and the smarter way to go, is what we call the delimited format, meaning that there is some character in the text file that represents spacing between files, saying, hey, this is one data point, this is the next data point, this is the next data point. And so click next, and you'll notice right away that there's a bunch of options. It typically defaults to tab, but very commonly commas are used sometimes, semicolons. Whatever the file size looks like, whatever the file looks like, use that one. And you can tell down here which one it is, because it's the one that makes it look like, hey, this data set looks like it's patterned properly, so we'll select that. So I click next, and it'll say, hey, does this look okay? What kind of data types you have? That really doesn't matter. You can always change it later. So you just want to say finish. And the nice thing is now you have this very lovely new data file that if you look down here below, you can see that the lecture file is listed as the sheet is the name of the file, and you have the data spaced here. So I'm actually going to copy this and bring it back into my other document just so you can see it a little bit better, and I can have this running track of where we're at in this file. But anyways, we have this data set, so that's great, and I'm not going to do that. I'm going to bring this over here. I'm going to do some quick editing and adjusting, and you'll notice here it has time in seconds, temperature here, and question mark C. That's not really what we want. So in this case, I'm going to do the Alt 0816 to get degree C, and we have that temperature now. That's lovely. So now what do we want to do? We want to plot this data to see how this time versus temperature was set. And this is just some random data. It doesn't really matter what it is of. This is just to show how we're how we can create a chart. So we want to plot this. The reason why we want to plot it is oftentimes most people are visual. We see trends much easier if it's graphically shown. It's the whole picture is 1,000 words thing. We like to see we can pinpoint differences very well, easier in a graph than we can in a table. So we can actually take this and go ahead and span across the column just so it can be prettier. At least I think it's prettier. So there we go. So now we're going to want to plot this data. So how do we do that? Well, it's a little strange, but you can get to all of your charting options, all your figure options, in this realm of what we call the insert ribbon. And then over here you see this nice little ribbon option saying charts. You want to select the data set that you want to plot in your charts, and I encourage you to list or include in that selection the names of the files, and you'll see that why in a second. But here you can see a whole bunch of options here in the charting. You'll notice, and I'll bring this, oops, I won't do that way. You'll notice you have a bunch of these options. In some cases you have this insert column, you have a bar chart, which is a column just on its side, you have this line chart, pie chart, and so forth. And this is important, and I'm going to emphasize this in this video enough. You do not want to use, for most data that we are doing in engineering, where you have an X value that is an independent value that correlates to a dependent value, a Y value, an X versus a Y. Whenever you have that, use the scatter plot. Don't use the line plot. Even though it seems like you might want to plot a line. Line plot is not a actual Cartesian coordinate plot. It just sequentially, evenly spaces all data values versus an even spacing. It does not actually plot out a Cartesian coordinate system based comparison data. So you want to go to your scatter plot. Always use scatter plot. You click the arrow down, and then you can select from here if you want it to be data points, data connected lines, smooth curves, or what have you. A little point for engineers: when we have raw data, especially data that was measured from something, we want it to represent that data by data points. Sometimes we'll include a line-to-line connection to aid visualization, but you do not want to do just for data a smooth curve, because that implies that it's a mathematical trend or model fit to something. The data point, usually when we see it in a figure, it implies that that data was collected and it's a discrete value that has no real direct relationship to the other points along those lines. But in this case, we definitely want that connection that those discrete points made. Later on, when we start to model or add data fits to describe that data, then we'll have that smooth curve trends and so forth to help to fit it. But this is just a very subtle point, but a very important one in the realm of engineering and science, that you want to present the data as data points. So with that said, you'll notice we get a nice little figure, nice little chart from Excel, and if you notice, this is what it plots out to, and I hope you can all recognize right away that it is graphically horrible. Excel is great and does its best to make graphs look terrible, and in an engineering realm it doesn't make any sense. You have your y-axis that has no label, so we don't know what X is. It's bananas versus monkeys, or what have you. We have no labels here. We have temperature at the top. I don't know why we define this as temperature when it should be actually the title of the chart, and it looks a little cumbersome. So importantly, and we're going to get to the next part here, is how do we edit this chart to make it useful? So we can do that by a variety of reasons. And the new model of Excel I'm not super crazy about, but I guess it is kind of convenient. You have all of the editing features here at your fingertips, so to speak, that you can change. You can change your chart style, you can change filters, but you can click on the button here and it pops up with everything you want to change with it. Every possible thing under the sun, which is great. And so the first thing that I encourage you, and this is if you want to have a checklist of things to do when you plot in engineering, add axis titles. Always. You can't plot something without knowing what that plot is. And you can title it here if you want. You can title it here. I'm just going to type it in here just because it's convenient for me in seconds. And down here, oh, I'm sorry, I just did it backwards. This is actually our y-axis, which is temperature. And I'm going to call this an alt 0186 degrees C. And down below, we have our axis title of time. Time in seconds. Oh, lovely. So now we know what we're plotting versus each other. The next thing you're going to want to do, and this is, I'm kind of teaching the standard engineering preference, and this may change wherever you go, but a lot of engineers hate the grid lines. I know I do. They kind of get distracting and tend to not aid in understanding the graph. It just kind of distracts. So you can select those and just delete them. Well, that looks goofy, so we'll delete both of them. So now we have a plot that's somewhat clean. And now, if we want to, we notice in this plot we have this trend of data that it has these x-axis, the vertical line up, vertical line across, or horizontal line across for the labels, but it looks somewhat barren. So I also like to go to over here, the next option, sorry. You can go to design or format, and here's another thing you can do to change things. So in this case, since I selected, you'll notice I selected the chart itself, this whole area here. I can actually add a shape outline to that and call it automatic, and we'll get a very nice box around the chart, right? And so we can, you notice again that the color selection here in the box here is a little bit different than over here. Again, Excel does these weird editing changes that I don't quite know why it likes to do that. So I'm just making it consistent so it's a solid black line all the way across, and we have this chart here. And then you have your temperature, you have your time below, and well, lo and behold, we don't have tick marks. So we can go into our axes, and where do we have that? Oh, if we need to make changes here in the axes, you can actually click on them, right-click the axis, and here it gives you the option of adding minor grid lines, adding minor grid lines, and so forth. But here we can actually just say format axis. And when we do that, we get a little side window pop out over here. And this side window, we have even more options. And so I know this is a lot to take in at once, but it kind of helps to see all the different ways you can get this information. And interestingly enough, let me close this out. Interestingly enough, whenever you select something now with this format bar open, whatever you select, it's now going to have that as your format. So it's a little bit, it's actually pretty convenient now that you can make a lot of changes and just leave this open appropriately. So here you can click on the chart, you get these axes options, and I can go down and look at tick marks, and I can say I want my tick marks to be on the outside, and I can do the same thing over here. Tick marks, major outside, and there you go. And that's starting to look a little bit better, right? I just think it's a little bit cleaner. You could even define, if you think the auto sizing or numbering on the axes is appropriate in both directions. You want to maximize the signal and understand what the data trends are. So sometimes you might want to add in, you can go to, where's the number or axis options. You can actually specify the units that are used for major. So if you wanted to double the number of data points that are given, I can just say 1 and you see that. So you don't have to take the default values that Excel spits out at you. And you sometimes want to play with it a little bit to make sure it looks good. So that's really, and that's how you can do a lot of changing. And you can shade it however you want and so forth. But you just really want to make sure that whatever you're creating is legible and clear and reports the information you want to report, right? And so I think this looks pretty good as it stands right now. It's not too bad. So we have that. But once you have a figure, and you'll notice sometimes this data may be, oh, I don't know, you might have not included new data, or you got new data that you wanted to include, or maybe a new curve line. So how can we do that? So we're going to get to the next question of just adding data to a chart. And so you could, of course, just delete this chart, take your new data set, add that in, and run with it. So I mean, for example, I can create a temp2 column, and I'm just going to make a random number generator that's going to multiply to this value. I don't know why, but just because I can do that. And drag that down, and there we go. So I could actually create a whole new chart by selecting all these together, go to Insert, and click Chart Scatter Plot, and I'll get a new plot with that random number generator plot and so forth. And that looks fine, but if you notice, the big problem is I now have to re-edit the whole stupid thing, and that just seems like a waste of time and not very interesting. So how can we do it alternatively? Well, we can actually take this chart, and if you look up above here, you have this format option and you have this design option. And selected inside the design option, you have this option called select data. And here you can start changing things up however you want. You can add data, you can edit data, you can remove data however you want. And so let's say, for example, we wanted to add new data to this. Well, then in this case we get this little edit window popped up, and whenever you see this little symbol here in Excel, that allows you to select range. When you select that, it minimizes this screen so that you can visualize the data set a little bit easier. You don't always have to click that, but it's just a point to note. So we can give this a series name. I don't know, let's call this data set 2. Alright, sorry about that. We had a small little malfunction, so let me try from here. So I'm going to go to select this chart, go to design, go to select data. Now we can go ahead and say we're going to want to add some new data. So select add, and we're going to call this data set 2. And we can go ahead and get into the series. So here we're going to select our X option, and then we want to select our Y data. Now, one of the things I'm going to caution you about, you notice this, whenever you see this equals 1, make sure you delete that and make sure it's gone, because sometimes when you select, if you didn't delete it properly, it'll be there and it'll give you weird errors when you try to create your data set. So you have this, that looks good. Now you can say OK, and you have now your data that includes 2 separate data sets. Very lovely, and we can go ahead with this. Now, of course, that we have 2 datas on one curve, we don't know which one's which. So you're going to want to add a legend to that case, and we can go ahead and just say add a legend here, and you'll oftentimes want to bring that into the plot and represent it however you want, right? If you want, you can add a box to it by adding a shape outline. You do automatic, or how whatever you think in that case looks fine. But that's in a nutshell the way you can format the data. Now, plotting of data, and I'm going to go ahead and just delete this data set, hit the delete key, because I just don't care about it at this point. That was just to demonstrate how you can add data if you need to. So the next thing I want to talk about is adding trend lines. So trend lines are the curve fitting that's built into charting, and this is probably one of the most useful, if not rudimentary, uses in Excel. Now, and it's one of the ways we can, when I mentioned in class on Thursday about the use of empirical models, this is what trendline fitting is going to be. We're talking about empirical fitting of data, just to relate it mathematically. Sometimes that can have a fundamental point to it, but it doesn't necessarily need to be. It's just a fitting of data. Now, later in class, in future discussions, I'll show you how you can actually use Excel to create your own curve fits on actual fundamental equations of state or fundamental engineering equations, and how you can use Excel to create your own trend lines. But in this case, we're just going to show you how you can use charting to give you simple ones, whether it's linear regression or otherwise. So, to do that, you can click over here, and you'll see this nice thing called trend lines. And you can select that arrow to give you options and so forth, or you can just select trend line. and go that route. Whatever you think is easier to you. You can select that trend line. Once it's plotted there, I'm going to get rid of this. Once it's plotted there, you can highlight it again, right click, because right click's our friend, and go to Format Trend Line. Now here's where all the magic happens. Let's bring this over here. Alright, cool. So, bring it back. Okay, so you have a bunch of trendline options built into Excel, and you can use this really quickly to see how behavior goes. Now, you'll notice in these trendlines options, you can specify whether it's going to be an exponential curve, you want to do a linear fit, a logarithmic fit, which it doesn't like because we have a 0 value. I'll let you, and then we just made it go away. Let's go back. Here's another way you can add a trend line, just to give you another view of this. If I select the data, and you notice you have all the data points that are highlighted. If I select that data and then right click on one of the data points, I can go here to say add trend line, and that'll give me another option to adding trend line. So yeah, clicking logarithmic got mad because the log of 0 is non-defined, and we have a data point 0, so it's like, what are you doing? But anyways, and so we can go to polynomial and fit data, and it's a little hard to see because of the zoom on this, so I'll bring this out. The polynomial will let you set the order, so you can actually have a quadratic fit, you can have a third order cubic, all the way up to 6 root, however you want. It's up to 6, so you can't do more higher polynomials than that in the trend line, but you have that. Or you can do a power law fit, which it looked like it went away. Why'd it go away? Let's bring it back. Data trends. Alright, and that doesn't like that right now. Okay, add data trends. And moving average, which is a more issue with economic plotting and so forth. But let's just stick with linear for now. You can go to linear and you go down further and you'll see you have options on how you want to represent the data. You can actually force the data to go through 0 at the origin if it's appropriate. Some models you may want to do that. You can also have it display the equation on the chart, which is again probably the most useful feature of this entire effort, is you can actually see what equation is being used to describe the data. A very nice feature of Excel plotting. And also, we can talk about this a little bit later, but we also can plot, and we'll talk a lot more in depth about R-squared values, but R-squared is your regression, your goodness of fit, so to speak, on the, or at least a measure of how good your fit is in terms of the plot. So it's not actually goodness of fit, but still, it's the value by which we can assess how much of the data is being described by the model that we're using. And the closer it is to 1, the better the fit. So you can see here R-squared value is 0.83, and you can kind of tell intuitively right now, and I hope that this data set is not well described by a linear curve, right? It's looking pretty horrible at this point, right? I think that's something we can all agree upon. Now, and that's what we really want to do, is we use some sort of visual representation to see how good our data set looks, to see if the model is agreeing with what the data says. In this case, we can fit it with exponential, and you see some deviations at early time points, but the exponential curve is a little bit better in terms of describing the data. It's still not perfect, but it's better. And you can tell, again, that the quadratic fit seems to be the best over this curve. I bet you any money, though, as we go further out, we plot it out, this curve is going to start to go back up, so it's no longer going to fit our data. And this is an important lesson, I think, that whenever we talk about a model fit, it's only good within the bounds of the model that we're talking about, right? It's hard to extrapolate. You don't want to extrapolate. Of course, one of the challenges with polynomials is we can always improve, and you'll notice the R-squared is always getting better as we increase the order. But that doesn't mean higher order polynomials is a better fit to the data. All we're doing as we do that is we are allowing for more wiggliness in the curve, allowing it to actually model the random variations that exist within a data set. And it's important for us to know, do we really need to model that? Or is that perhaps these up and downs that we're seeing in these trends, is that really there? Is that a real phenomena? Or is it just error in the way we collect the data? And that, I think, is an important view for an engineer to understand and have an intuitive sense of grasp of, is when do we accept a model and when do we say, no, that's just part of the error associated with that. And that goes to my final point that I want to talk about in these charting plots here is, and that's including of error bars. Oftentimes, I'm going to delete this now, this trend line, just for the sake of deleting it. There we go. Oftentimes when we have, delete this plot too, when we have data, we don't always have it as a single data points. Oftentimes we'll take replicates or have multiple measurements at a single time point or otherwise. And this will give us a chance to do statistics over that will have what we call error values plus or minus around that single value. If you take three measures at, say, time 0, and you average them, you get standard deviation, you can get a standard error, and we can plot that. So let's, if we, and we can plot that. So we can add error bars to our plots. Let's call this standard error. And we can plot that, and I'll show you how you include that right now. Importantly, I'm just going to create a standard error mock-up. Let's call this a random number times I don't know, 10% of this value. So I don't, let's see how this goes. We're just giving random data set errors. You know what, let's make the errors worse. Let's say the standard error is I don't want to do it that way. Random's going to be from 0 to 1. It's always going to be a small number. So yeah, let's say let's give it 50%. So these error bars are going to be huge. So there you go. Now we can add in our error bars by selecting our data again, going here, and going to error bars. And you'll notice if I hover over it, it instantly gives us these error bars, both in the positive and the X direction and the Y direction. You can add both. And what are these numbers here that it's adding? Who God knows. It's just made up values that Excel is putting in there. And that's not the ones we want. So you click the error. It can give you standard errors. That is just you're specifying in. That's not actually a value. It's just a constant for all data points. I wouldn't include that. You can give a percentage over the data set. Again, that's just not what we're doing as engineers. Each data point will have its own independent error, typically in real data. So we can go to more options. And if you go to more options, and again, this is always disheartening that we see weirdness in the Excel, but I'm going to highlight the Y-axis error bars and delete those. And then I'm going to go to the X-axis error bars and delete those. I'm going to go to the I gotta go back, and I'm going to go to the X-axis ones. This is what we really want. The vertical error bars, the Y-axis error bars. And if you scroll down all the way down here, you'll see error amounts. You can have a fixed value of 1. I don't know why you do that. If we had a fixed value of 25, you'll see enter very large error bars. Again, this doesn't mean anything. You can select the percentage standard deviation, but what we really want is custom. And here, custom, we can specify a value. And the nice thing is we can specify a value in both the positive and negative direction. So in this first one, I'm going to highlight this, delete that value, and oftentimes error bars are going to be the same in the positive and negative direction. I mean, they should be. And you select this, click OK, and we now have our error bars that are associated with our data as we plot through. And that's it. This is, and so I didn't mention again, this isn't a time where we're talking about how you would actually calculate standard error. That's for a different class, a different lecture. But if you have the standard data, error data in a plot, this is how you can represent it on a figure, on a general plot. And of course, in the end, if you want to include a title above the chart, the temperature of my, I don't know, temperature of stuff. And whatever that is, and so however you want to title it, whatever you want to look at, you can add that. and then you could either copy and paste this entire chart into a plot, into a report that you want later, or just report it here. But in a nutshell, this is how you create charts. There are a lot of other options, but I think this is the one that's of greatest value to engineers, and I think that is all we will deal with here. On Tuesday's lecture in class, we will give some in-class examples of running this together so that I make sure we can do this, as well as some other courses from the other videos that we've done, and we'll go from there. So thanks and have a great weekend.